We're going on to topic 6.2, which deals with exponential functions. So we could put a function symbol there, but we would convert it to y. Y equals 2 to the x power. And we're wondering, what would our y values be in this case? Well, if x is 0, any number to the 0 power is 1. If x is 1, 2 to the first power is 2. Now, if we had 2 to the negative 1 power, we just bring this down to our denominator, and it actually becomes the reciprocal of 2, which is 1/2. Now, if our exponent is 2 here, our x is 2, 2 to the second power is 4, and 2 to the negative 2 power is the reciprocal of this, that is 1/4. And 2 to the third power is 8. So what we're going to do now is to graph these points, and we'll start off with our first one. If x is 0, our y is 1. So we put a dot right there. If x is 1, our y is 2. So we go right there. If it's a negative 1, x is a negative 1, y is 1/2. Right about there. If y is 2, x is 2, 1, 2, we now go up to 4. 1, 2, 3, 4. And if it's a negative 2, it goes down to 1/4. Now if x is 3, 1, 2, 3, this now goes up to 8. So 4, 5, 6, 7, 8. Now notice we have developed a basic curve for this particular example. So I'll sketch that in for you. So this is what it's like. That if we have y equals 2 to the x power, that is an exponential function, our curve looks like this. Now this line is going to get ever and ever closer to 0, but it never quite reaches 0. We call this our x asymptote. This is the x-axis, so our x-axis is the asymptote. Never quite reaches it. And of course it goes off to infinity up in that direction. Now what we sometimes wonder is, suppose we change this 2 to a 3 now. 3 to the x power, what would that become? So let's put in some new values here. Now I just erased it a little, and let's go on. So if x is 0, we're replacing our exponent with a 0, we have 3 to the 0 power. Well, anything to the 0 power is 1. Now, if x is 1, this is going to be 3. And if x is a negative 1, it becomes 1 over 3 to the first as we bring that exponent down. And in a sense, it's the reciprocal of this. So 1/3. Now, 3 to the second power is 9. And to the negative 2 power is its reciprocal, 1/9. And this gets to 3 to the third is 27. So this is way off of our graph. But we may see a trend as we plot these. Now, 3 to the 0 power in any of these always goes through 1 here. But now if x is 1, this goes up here to a 3. And this goes down here to 1/3. And if it's 2, x is 2, this goes up to 9. So 4, 5, 6, 7, 8, 9. And we now get this curve. Let me sketch it in. So we see if this were 2, we get the black line. Now the blue line is y equals 3 to the x power. And what has happened, we have moved our graph toward the y-axis. We have shifted it toward the y-axis. So a question is, where would y equals 4 to the x power be? Well, we would just change these numbers, and again, anything to the 0 power is 1, but then 4 to the first brings you up here, and then 4 to the second brings you up here to 16. So let's put a different color on that. So as we go up in powers, or our base is 2 or 3 or now 4, the line shifts in closer to the y-axis. And these get closer still to your x asymptote. But never reaches it. So this is if your whole number, or these are whole numbers. How about now if we make this base a fraction? What would that look like? Now, if our base is, let's say, 1/4, and we're going to raise 1/4 to the 0 power, anything to the 0 power is 1. Now, 1/4 to the first power is 1/4. Now, 1/4 to the negative first power, we had said if this is a negative exponent, we just flip this around and this becomes 4 to the first. So in a sense, if we have 1/4 to the first power, we got 1/4. But if it's 1/4 to the negative 1 power, we just take the reciprocal. So this is going to be 4 now. Before it was the other way, now it's this way. So 2, this becomes 1/16, and then 1/4 to the negative 2 power. We just take the reciprocal of that. That will be 16th. And this gets to be big numbers, so it's off our graph. So let's plot these. And I'm kind of running out of colors here. I'll stick with the red. Now, if x is 0, y is going to be 1. So it's, again, all of these go right here. But now if it's 1, it's 1/4, so it goes over there. If it's negative 1, it's actually 4. So up over on this side now. 2, go over 2, is 1/16, so very close. And then now this goes up 2 to a 16 up there somewhere. And if we draw that graph, and through the magic of cinematography, hopefully you can see now that this red line and this red line are reflections of each other along our axis of symmetry, which is the y-axis. And you might wonder, what is the equation for the y-axis? Well, that equation is x equals 0, which is a vertical line, which is actually the y-axis. So this is our axis of symmetry. And when we have y equals 4 to the x power, its inverse, in a sense, is y equals 1/4 to the x power. Now, if we were to draw 1/3 to the x power, that would be over here where the blue line is. And if we did 1/2 to the x power, that would be the reflection of the black line. So as these fractions, 1/4 is close, 1/3 moves out, 1/2 moves out further, the same as we see on this side. So these are some graphs of the basic exponential functions. You'll be working on this, and we'll be doing some other things as well.